But right now, we are actually directly moving into one of my favorite parts of the day, which is our live product demo. My colleague Florian Siemenroth is going to lead us through the demonstration, and he's joined by Gina Greco, Lea Hellweg, and Elfi Töpfer from our partner companies, so that they can also give you all the inside information into their products specifically. So, Florian, the stage is yours. And everyone have fun with it.
Yeah, thank you. I think first of all we have a quick question from as I'm informed.
So I hope you all still have Menti open, and we have a new question that's going to be shown in just a second. Again, if you want to open Menti, it's the link in the chat or the QR code. So yeah, our question is, do you currently use microfluidics, as in micropumps, microvalves, sensors, chips, all the other microcomponents there might be in your company or department? The answers range from yes, it's like the biggest thing ever, to not really. I also really like the answer. I have Googled it already. So yeah, make sure you just oh, it's really great to see that all of you, or a lot of you, actually know a lot of microfluidics.
So our marketing strategy for this event works quite well, I think. So because
yeah. I mean, I personally am Googling microfluidics a lot during the day, but that's something else. Okay, Flo, I guess you have a lot of experts sitting in the audience today.
Yeah, sure. It's not surprising, but I have not thought that this would have such an impact in the research.
20 Leute, das wäre ja wenig.
Pardon? Sorry. However, then maybe some things that we are showing today is not completely new to you. But first of all, I would like to introduce, well, somehow partners, somehow colleagues, somehow friends of mine. Lea Hellweg from Mimetus, Gina Greco from Sensorion, and Elfi Töpfer from ChipShop. We are working quite closely together, as they are component manufacturers as well as we are. And the single components have a very good fit to each other. So that's the reason why we have a lot to do together. And that is why we are presenting ourselves today mutually. And maybe just a quick hello to all of you.
Hello.
Hello, welcome.
Thanks for joining.
Yeah. Thanks for supporting us today. And we will have at first we will have a mutual presentation, and afterwards I will share some of our components in a live demo. And in this case, feel free to ask any questions during the presentation, especially during the live demo. So we really want to have a flexible discussion. I'm not quite sure whether this works online, but let's give it a try. So I will quickly start with the presentation, and Lea will follow me afterwards. Sharing my screen now. All right. Sorry. Sorry.
The screen, okay, shows just.
I know. Sorry. Just hang on a second.
This is part of the demo, of course.
Yeah, sure. All right. I think here we. Yes. Here we go. All right. So sorry for that. Today we want to talk a little bit about readily available components, actually. So we have talked, our previous speakers have talked about microfluidics in general, and where microfluidics come from and where it may go. And today, here in our slot, we want to have a look at currently available components and what we can do with those components. And what we at Bartels do is something like we really, as Frank has already mentioned, we really gathered experience like 25 years now in microfluidics and microtechnology in general, but especially in microfluidics. And we are equipped with some microcomponents. And these two things combined, like microcomponents or microfluidic components with microfluidic know-how, that's our vision at least. We want to solve issues with microfluidics in industries like life sciences or industrial applications. And therefore, we have got, of course, our single components, especially in our case, the micropump. Lea will probably talk a little bit about microvalves, Gina about sensors, and Elfi about microfluidic chips. And all these components will lead to a complete fluidic or microfluidic solution. And nowadays, we really have a readily available set. In this case, you see some pumps, flow sensors, active valves, drivers, electronics, pressure sensors, etc., etc. So you can have a really highly functional system on a very low footprint, modular, flexible, and our task in the microfluidics industry, it is to make these components accessible for the industries or for the customers in the end. So this is it for the Bartels components, but let's switch to the Mimetus components now.
Thank you, Florian, for the introduction and all the things you said ahead about Mimetus valves. So we do valves. We are specialized in microactuation and fluid control based on shape memory alloys. Shape memory alloys, that's a material, a metallic alloy that can be easily deformed when it's cold, and when we heat it up again, for example, by an electric current, it will go back into its original shape. And this is exactly the movement or the performance that we use to perform this movement, to switch our valves or to have a stroke with a specific kind of force. This material has especially a very high power density in the lower mass range. That means that we can build especially very small and miniaturized components that are still quite powerful. So for example, these valves, these small valves that you can see there, they can still switch a pressure of up to 2 bars. So you can see here the Mimetus portfolio. So we have 2 kinds of standard valves that we offer, a normally closed one and a bistable one, both two-way configurations. But we also do offer valve customization and customization of actuation solution. So whenever you would need a small valve or a small component that performs a movement in your system and you really don't have much installation space, you should have a look into shape memory alloys, because it's a really great technology for small sizes and dimensions. So but apart from the valve customization, we also do develop fluidic systems. So as Florian mentioned, we work closely with different partners together. We also have a skilled team of engineers here and many rapid prototyping technologies in-house, so we can deliver the whole fluidic system with different components as a ready-to-use solution. And for all of these 3 areas, of course, electronics is also highly relevant. We provide therefore some ready to use and easy to use electronic control units, so you can quickly start testing our valves, also with a graphical user interface. But we also support you if you rather would decide to integrate the valves in your the electronics in your existing system, we can help you to implement that. And of course, also provide a standalone solution. Yeah, having a look at the advantages of Mimetis valves. So you will certainly save a lot of space in your application because they are, yeah, as you see, very small and compact, but also very lightweight. So even if you use many of these valves in your device, it won't get very heavy because we mostly use plastic parts, and this shape memory alloy actuator inside the valve is a very thin and small element. On this picture here on the upper left corner, you can see the inlet and the outlet of the valve on the bottom side. And inside the valve, we really have very low internal volume of less than 4 microliters. So you won't lose too much maybe expensive reagents or consumables inside your device when using the Mimetis valves. Also, this is sometimes very important if we think about life science applications and cell cultivation, etc. You may want to have a very smooth control of the flow, a smooth switching of the valve. And there, the shape memory alloy technology is a stepless technology that switches really smoothly. You can combine it with a, for example, flow sensor from Sensirion to really have a precise flow control with the valve. The valves only consume very low energy, so that even would make battery operation possible, maybe for portable applications or handheld devices. This is important. And the valves are media separated, so that means that the liquid or the gas will only be in contact with the lower part of the valve, the white part that you can see, and a flexible membrane inside the valve. The valve can be flange mounted onto a backplane where the whole fluidic logic is integrated. So that means you could get rid of all the tubings and have all the valves stacked on one platform, maybe also put a PCB on top to have really a compact, smart valve manifold system. That's why we chose a flange mount connection. And last but not least advantage is especially the silent operation of the valve. If you want no disturbing noises nearby, you should use the Mimetis valves in your device because they switch silently with this technology.
Thank you, Lea. So it's your turn, Gina.
Thanks, Florian. Thanks also for inviting me. I'm very happy to join. Here's a very quick overview on Sensirion. We are expert in sensor technology from macro to micro fluidic scale. So we really cover many different flow ranges, not only the one in the microfluidic scale, which are though the most relevant for microfluidics and life science application. We are a global market and technology leader in liquid and gas flow sensors, but also concentration and environmental sensors. We cover different markets. Inside the industrial market, there is also the life science, diagnostics, and analytical instrument market for which I'm responsible. And what we normally do is to push a lot our innovation. We normally invest between 20 and 20% of our revenue in R&D. And especially focusing on life science application, we also have solutions that are biocompatible and also application-driven solution. We really like to shape and develop our sensors together with our customers. It's not about selling a portfolio, it's about solving problems. So that's how we approach every time new projects, and we learn from this so that we can develop further our sensor. So here on the right, you can see how our sensor changed over time, over the years. One of our biggest know-how is the miniaturization. The ultimate goal is to have a complete solution on a single chip. And that's what we try to do every day with different sensors. So here you see a humidity sensor. At the beginning, we could have some tens we could manufacture just some tens on a wafer. Now we have thousands and thousands. So because we could miniaturize it. And there you see also our CO2 sensor. which is now less than 1/6 of how it looked like before. And we provide also leakage detection sensors. These are particularly relevant for safety reasons for refrigerant applications. And then we go with liquid flow. It's like the most used around in microfluidic applications, where we have the smallest one available in the market. It's 1 centimeter square. If you could please go to the next slide. Thank you. So in general, what Sensirion brings with our solution to the life science market is that by using our sensor, you can achieve a precise liquid and gas handling, which is extremely relevant, especially to improve stability and repeatability of instruments. It's a bit of what you heard at the beginning during the introduction. Sometimes microfluidics is really hidden in macro devices, and still sensors are needed so that this balance and this stability can be achieved. And having digital sensors that continuously give you feedback information also avoid downtime of the machines, because then some alarms can be set. For example, in some of our liquid flow sensors, there is bubble detection, so air inline detection alarm or overflow alarm, and then this could trigger some alarms in the system that can automatically block or have some solutions implemented. And that's it from my side. So I guess it's Elfi's turn.
Yeah, thank you. Elfi, it's your turn.
Thank you, Gina. So I will just take over. We're a microfluidic chip shop, and as the name might already tell, we're all about microfluidic chips and microfluidic chip production. We focus mainly on chips made from thermoplastic materials. As you heard, we're not so much a fan of PDMS from Holger already. And we do have different columns of business, I would say. So first off are our off-the-shelf products, and we'll talk about them on the second slide. So these are components you can quickly order and use and try and get an intro into microfluidics. And these are also the components that Florian will use in the demo that we will start in a few minutes. Of course, we also do customer-specific development and manufacturing. So just contact us and say, I do have an assay and I want to bring that onto a microfluidic chip. Can you please help me? Or you already have an idea of exactly what your microfluidic chip should look like. This is where we come in and we help you designing and manufacturing these things. Also, what we can help you with are complete systems. So if you not only need a chip, but you also need instrumentation to run a chip, we can help you with developing this entire microfluidic world, basically. And we're also always very happy to engage in collaborative R&D projects. So as Holger maybe mentioned in the beginning, we're happy to involve in EU and in national projects and so on. And that is where we basically get a lot of knowledge and new developments from, where we can try things. So if you have maybe sometimes a crazy idea, you can contact us and say that is something that we might want to tackle within a research project. Flo, if you can go further.
Mm-hmm.
Okay. I think today we will mainly focus on our off-the-shelf components that you can all find in our Lab on a Chip catalog. What is quite nice there is that it, I think, now has more than 300 pages, and it's really like a microfluidic Bible. You can spend several days just studying it. What you will find is that you have over 1,000 microfluidic products. These are chips, accessories, partner components, and things like that. And when it comes to chips, we do not only offer a very big variety of complexity and of application on a chip. So you can already see that in the slide here that we have simple flow cells, chamber chips, chips with membranes and so on, where you can try things from droplet generation to cell culture, for example. But these chips also come in different materials. So depending on what kind of material compatibility you're looking for, that is covered with the chips as well. And they come in standardized formats. So a lot of them are actually come with in a microscope slide format that are easy to use, and that it will be quite common for many people that come from the biological area. And they come with standardized interfaces, which helps then to connect them to partner components and so on. That's really all I want to say, and I think we can start with the demonstration.
Yeah, thanks Elfi, thanks Lea, thanks Gina. I think in the meantime we will have another poll, okay, if I'm right. Before starting the demo, I'm getting prepared while you have to answer some questions. Yes, this is meant like something you've seen or you've recognized that we have all components and that are quite modular, but what would you like to use more? Modular setup or an integrated system? All right. It's roughly 50-50, I would say. What would you think? Oh no, not more, not anymore.
Let's see. It's interesting.
For my experience, that also depends a lot on what people's background is.
Right.
I think people from with a biological background like to use black boxes because they're quite used to that, using kits and so on. And people with an engineering background prefer to do things themselves and put things together in the way they want to.
Yeah.
So is that we have more engineers today rather than biologists?
Potentially, I don't know.
Interesting.
That's just a personal observation, so I might be wrong.
I also like the contribution in the chat with how about both modular and R&D working towards an integrated system.
Yeah, I've seen that too, and that fits quite well to what Elfi just said, I think. So I think the Microfluidic Society has to do both to be helpful in the end.
Definitely, they do not exclude each other. It's mainly how they are used in the end. Okay. Because if one just needs the output, why should care about the modular setup? That's also true.
Okay. Sorry, I will already start to share my screen, and you can keep up the discussion, please.
Yeah, that's also what I wanted to say. This is what one of our business models is, that you actually take a modular approach to then develop an integrated system, so you can try things out.
Yeah, there is a very good point in the chat. Han wrote, modular with very short connection lengths bridges the gap between modular and integrated. That's also true. And the step before, it's what Elfi mentioned, that in the end, you need typically the modular approach to have the black box.
All right. So now you should, now everyone should see my screen. Is that correct?
Yeah.
Yes.
Yes.
Fantastic. All right. So let me quickly go through the setup actually. So what you can see here are some components that you've seen on my last slide actually. Here are two, or rather three, of our pumps. A liquid flow sensor by Sensirion, a Honeywell drug pressure sensor, microfluidic chips in the handling frame by Microfluidic ChipShop. Also some valves by Mimetus, some normally closed valves, shape memory alloy valves, and some other components like here. I've got a optical sensor, check valves, pulsation damper, and something like, well, the engine of the whole setup is a microcontroller-based circuit board running or reading the components. So let me quickly plug the system together. I've shown you it like in this way because now I need to use cables, and it looks very clumsy in a second, I would say. So I hope everyone could follow me. Yeah, so I will, first of all, I will connect the micro pumps to the drive board. Like this. The pumps are actually piezo-based micro pumps, 2 piezo actuators in a series setup with a phase shift of 180 degrees. So while the first one is sucking, the other one is pushing the fluid. This pump actually runs a bubble trap, which you will see in a second. So the 2 pumps are actually connected to the memetis valves, so I can distinguish between. Oh, by the way, the micro pumps are able to pump liquids and gases. So this is what I want to share with, in the demo. I want to run liquids and gases, and that's why I'm using the memetis valves to distinguish between the 2 of those liquids, fluids. Yeah, maybe Lea, do you have anything to say to the memetis valves, like the working principle? Is there a spring inside or something? I'm not a big expert.
Yeah, as you mentioned, they can switch liquid and air. The principle inside the valve, I mentioned that we have the shape memory alloy actuator implemented in the valve, and this actuator is pushed down by a spring element, as you said, actually, onto the valve opening. So a valve seat, we have a valve seat, and there's a ball pushed by the spring onto this opening. And now if you connect the current, apply current on the valve, the actuator will heat up and push up the spring to the top, releasing the ball from the valve seat, and your liquid or your air can flow through the valve. So that's the principle of the normally closed valve. So it's closed as long as you don't apply any current.
Right, nice. And I'm actually using the straight channel chip by ChipShop. This is this one here. 4 different inlets or outlets for 4 different channels. I'm not quite sure actually which one I'm using at the moment. Elfi, do you recognize it? Can you estimate?
As I said, we have thousands of chips, and from that far, it's probably difficult to see. But what I can tell you this is one of our standard flow cells where we have 4 channels on one chip, and that is really what we like to do. That we have several fluidic pathways within one chip that helps to save setup costs, because within one chip you can run 4, sometimes 16 experiments, because we also have chips that have, for example, 16 chambers or 16 channels. The chip you're using right now is really relatively simple because it's a simple flow cell, but you could also use any other chip from our catalog that is able to mix different components. You could have filtering chips, you could have chips with membranes, and so on. So really a lot of variety.
So luckily we have a lot of space still for some more of the memetis valves, so maybe we can switch even more channels than the 4 we can see here.
Exactly.
And I've actually already seen a prototype, at least, or is it a prototype that the memetis actuator is directly on a microfluidic chip or ChipShop?
Yeah, we also have such a chip as you have it here, but fully mounted with all the valves on them. But I'm not quite sure how many fit on the chip actually. But
I think we have. I think we made on this slide format 8.
8
for a prototype. I think so.
Mm-hmm.
And that is quite nice, really, for more complex experiments. And what you can also do, of course, is not only having one microfluidic chip, but daisy chaining different chips with different functionalities after each other. So you can mix different components, then bring them together into a reaction chamber or things like that. And this is all in the footprint of a microtiter plate. So that's quite impressive, I find.
And the last component that I've nearly forgotten to connect, actually, shame on me, was the
Shame
flow
on you.
was actually the flow, because it looks so packaged, as it looks as if it has got wireless connections or something. So already something like a battery or so, but it's not battery powered. But what's the magic behind the measuring principle actually of the Sensirion sensor?
Yeah, so here this is actually one of our latest liquid flow sensor. And now maybe I can describe it in my Italian way with gestures, of course. So the measurement principle is a microthermal principle. You have a heater in the middle and then on top of a membrane. And on the side, you have two temperature sensors. There, when the liquid is flowing, it will carry the heat generated by the heater at a speed that is related to the speed of how the fluid is moving inside the channel. So by measuring the difference of the temperature between the two temperature sensor, once the heater is on, which is a micro heater, which doesn't influence at all the measurement, of course, we engineered that way, then we can say what's the flow of the liquid inside. And then you can also measure the temperature of the liquid. And as I was saying before, this is the sensor that can also have some alarms in case there is air in line. So if there are bubbles or if there is an overflow. So if it's exceeding what the sensor can measure.
I actually also love the functionality of measuring. So there are sensors from the range that are able to measure thermal conductivity, and so that you're able to distinguish between liquids, for instance.
Yes, that's a feature. That's another feature. So on top of all these measurements, one can measure the thermal conductivity. And in this case, imagine you have a user that needs to inject different liquids. By using the feature of measuring the thermal conductivity, one can say, oh, wait, this is the wrong liquid because we didn't expect such value of thermal conductivity. Or one could even measure the concentration of a liquid in a mixture, because then as soon as the volume of a liquid in the mixture increases, then also the thermal conductivity would change accordingly. So there are many applications around also this. Yes.
So what will happen in a second is we will blue colored water running through the fluidic setup, and the flow sensor measuring the flow rate, the pressure sensor measuring the pressure, and the optical sensor, which is on analog 3, right? Analog 3, measuring whether there is something inside. The optical sensor. So let me quickly switch the valve and start running the pump.
Maybe I can throw in some questions that we have in our chat.
Sure.
I just saw that we had a question that asked, what is the lifetime of a piezo pump? That would be for you, Flo.
Our micro pump has got a lifetime of a guaranteed lifetime of 5,000 hours. We see actually much more in our long-term measurements in the production, but due to the fact that our piezo manufacturer guarantees only 5,000, we hand that on to our customers as well.
Okay.
So just a quick comment on that. Now you see here the flow rate. So what I want to say is actually this setup or these components with this easy access is already commercially and industrialized, commercially available and industrialized. So you can get everything that you see here within a few days, I would say. And we try to open that setup with a very easy access with such an app. So you can do several things in this app. For instance, reading the flow rate or measuring the pressure, or distinguish between gas. Let's see whether that works. If I run gas now through the system, you will see in a second that the optical value will change from the liquid, from the water calibrated value to the air calibrated value, so that you can already distinguish between air and liquid. And on the other hand, you can do some cool stuff like a little bit of automation. You can control even more pumps, up to 6 on that board. You can read the flow rate in a graph, and you can even store the data that you've generated. And of course, you can easily switch valves. Like I'm switching the valve now, and we do not see any flow rate anymore. Opening it, and we will have the flow rate again. If I want to run this, actually, I want to share with you the idea of a bubble trap here. So this is why I generate a negative pressure inside the bubble trap now with this pump. And if I let gas into the system, the bubble trap will make sure that no air will reach the chip. So it protects the chip regarding oxygen. Maybe they can see that it gets into the bubble trap, but not out. Maybe, okay, now it's small one, but however, not that much as it as I have let into the system. Maybe Elfi can elaborate a little bit on issues regarding oxygen in biology experiments with microfluidic chips.
I think I can in general say something about bubbles in microfluidic chips. This is I think one of the most painful things that most people that have worked with microfluidics experience. And there are certain things that we at ChipShop already like to implement in chips, because sometimes air is not only coming in from a pump, but also if you have very different temperatures within the liquid. The liquid can degas, so you should always work with degassed liquids from the starting point. But if you do, for example, PCR applications, having small air bubbles in the system is nothing that would be surprising, and then you should work with the readout system that helps you not to catch the air bubbles, but make sure that those bubbles that develop move away from any readout area and so on. So there are different ways to handle that, also just from a chip perspective, I think.
All right. So long story short, there are microfluidic components already industrialized and in high batch production available. And our goal is, and that is why we work so closely together, is to make them work together. And this is one example from us that we can do here. I'm not quite sure whether we have got some time for another experiment. Otherwise,
I don't think we are already a bit over time.
And we have so many questions also in the chat. I just saw. So we had, especially on standardization, Hannah asked some questions, and on valves as well. So I don't know if we have time to answer these questions,
sure.
or if we can do that. How fast does the valve switch, and what about power consumption, Lena?
Yeah, so for switching the valve, for opening, it will be faster because it's an active opening of the actuator. So it's around, I think, 70 milliseconds for this valve, and for closing, it's a passive mechanism because the shape memory alloy has to cool down again, and this will be a bit slower with but still fast, I think, so with 150 milliseconds. And for power consumption we have 0.3 watt, which is also really low, so for battery operation even.
I see that there is also a question on the liquid flow sensor. Is there any fluid resistance due to the flow sensor? So we offer sensors that are optimized for different ranges. So also the diameter of the microchannel inside is typically optimized for those flows that then can either be the very same diameter, so then you basically have everything consistent between the chip, the microfluidic chip, the tubing, and the sensor. But also sometimes there are some adapters that still make a nice job. But nevertheless, there are many ranges. So one typically finds the range that is ideal to avoid the resistance or a significant resistance there.